Thanks everyone through here. Welcome to the Demo Hub. In today's tutorial, we're going to see how to fine-tune large language models or LLMs using Snowflake Cortex. We'll explore how a fictitious medical company called Medisno can enhance their customer complaint analysis through this advanced technique for taking open source models, fine-tuning that efficiently in Snowflake, leveraging Cortex, and being able to deploy. As always, links to this tutorial is all available on the DemoHub website, the Medisno Commons model, which has a devices table as well as the customer complaints. You can get this set up in your environment by instantiating the script. This gives us all the data needed to follow along with these tutorials. What this does, it creates a new database for us, Medisno.db. Leveraging database, we're going to create two new tables, a device table as well as a customer complaint, and inject that with proprietary high-value data not available to the publicly available LLMs. Do a refresh. We now have a table here for Medisno ready to go with proprietary data. Next, begin writing our queries against this to validate the data within our table we've just loaded. In this case, customer complaints. You can take a look to see what complaints customers have, as well as devices. This proprietary product lines from Medisno. Here you have a device name, in this case, Global Medic 5000, device type, manufacturer, model number, serial number, some pertinent dimensions, warranty information, and more importantly, the business unit. Go over to complaints, look at what the customers using these devices are talking about. We have a complaint ID, device ID, so you can join those two tables. We have the date of that complaint, in this case, the customer using this device called Medic 5000 has some disappointment with this device. Part of this exercise is, can we take the open source Llama, fine tune it? Looking at this complaint, we can automatically tell the business unit that manufactures this particular device. Now, to do fine tuning, there are a couple of things that are important for us. You obviously need a training data set and you need some form of a validation data set. I'm creating a new table based on that, joining the customer complaints, which doesn't have the business unit, and I'm pulling the business unit from the device table to create a new table for training the model. We have a new table called model train. Do the same for model validation. Go ahead and refresh this. Model train, model validation, take a look. It tells you the prompt and the completion. Essentially, you are giving it the prompt and telling it what we expect as a response. This is what we're using to actually train the model. You need your training data to be in this format. It's always going to be a prompt and a completion. If we see arrow scan plus in this complaint, we want to complete to say the BU that manufactured this was Rena K. Now, with the training and validation data already, go on to the next step to actually do the fine tuning. If you blink, you might miss me doing the fine tuning here. Pay close attention. Copy the script for the fine tuning, bring this over into the Snowflake worksheet. We're using the Snowflake Cortex fine tune. This is a function available in the Snowflake environment, going down to Cortex. In this case, we're looking at the LLM function, which is a fine tune. The fine tune takes a number of parameters. One is create a new model, call it device Llama 3 8 billion parameter, because we're using the base Llama 3 model for this fine tuning. You can fine tune the 70B parameter or some of the larger models, but taking a smaller model, fine tuning that with your own proprietary data could be more cost efficient than taking a bigger model and trying to work with that. It's just something to take into consideration. This is the prompt for training. Run this, change your warehouse size accordingly. In this case, I'm going to keep it extra small. That just tells you the power of Snowflake. So easy to do. Executing this, it initiates, and this is a script that is decoupled from the UI. Once the script and the fine-tuning has been instantiated, you don't have to wait for the fine-tuning to complete. That fine-tuning is in progress. What you can do is monitor the progress of the fine-tuning. Run these two commands, the command to show, a command to describe. We see there is a job in progress. If you had multiple jobs and you run the show command, very similar to the show commands in Snowflake, you're going to see the jobs you have in progress. Next, do a describe if you have the GUID of that job, which is why it's important to capture the GUID of that job and save it as you initiate the job from above. This takes a few seconds and job is successful. Validate that by seeing a success coming up in here. The job is no longer in process. We now have a successful job. You can also validate that by going over to the models repository. Here we have a new model created, which is a device llama. This is the model we fine-tuned based on the proprietary data available for this company called Snow. Now, fine-tuning is one thing, but putting that to use is the next thing we're going to have to try with this model. Take over the script, bring it over to the UI. Two things are happening here. One, we can prompt for the regular Llama 3 8 billion parameter model. We're giving it a complaint and we want to know, look at the complaint and simply tell me what business unit manufactured this. Going with the Llama 3 8 billion parameter model, we should expect a problem. Reason is this model hasn't been trained or doesn't know the proprietary data of this company. If you look at the devices that were in this company, those are unique proprietary data in their SAP systems, in their manufacturing systems that Llama 3 doesn't know. It proves it by giving us responses like this. It doesn't know what a BU manufactured that because it just wasn't trained on that knowledge. Sometimes it even hallucinates and makes up names that are not necessarily helpful. This is not what we want. And this is where fine-tuning becomes an important piece to continue repeat the test. But no matter how you approach this test, you still will not get complete or good results. In this case, we're doing the same test, but we're using the 70 billion parameter model, so a little bit of a larger model. We still don't get the correct answers. Relying on those regular open source models, sure, they are good for generic tasks, but for your specific domain knowledge in your organization, those models are going to fall short. Now, let's test the models we've fine-tuned. The name is device_llama 3 8 billion parameter. Now, why did we fine-tune the 8 billion as opposed to the 70 billion? There are conversations to have around that. For one, it's cost. It's way more cost effective. If you can use a smaller model, fine-tune it with your proprietary data, it could be more cost-effective than just working with the bigger models. Hopefully that gets the point across. Here, we're doing the same thing, asking the same questions as before. Hopefully we don't get all of these answers that are not correct. Test this using our fine-tune model. Passing again the complaints. It should tell us what device manufactured that device name, and it should give us a BU, and the BUs are correct because this is what we have in our database system, and we fine-tune this model for that. You can see, even with sentiment analysis, it tells you the device name, complaints data, and it gives you a sentiment on this. The reason for showing this is that just because we fine-tune doesn't mean the model can only respond to the questions from the fine-tuning. Looking at this, you might have a workflow of doing sentiment analysis on your customer complaints, and based on the negative sentiments, reach out to the BUs that are resulting in the most negative sentiments. So there are some key points to consider here. Compare your baseline models with the fine-tuned models. Make sure the task you're using in this case is specific. Fine-tuning is not for every task. Some cases you might want to build RAG applications, passing in context, which prompt engineering. But in some cases, just front load that cost, have a fine-tuned model and work from there. The beauty of this tool is once you've done your fine-tuning, everyone within the organization now can use this as a starting point for their inference and even further fine-tune this model. As always, links to all of this is in the description below. If you want to follow along step by step with fine-tuning as we've done, go ahead and try it. This has been Fro with DemoHub. Thanks for watching and sticking to the end. I'll see you in the next demo.